So the rest of the section, these are really classic algebra problems. And I'm going to solve them with boxes. I have boxes set up already. I'll try to explain what's going on as I read through the problems. When I make these kinds of problems up, I very consistently use 100% duplicate questions, except I just tweak the numbers. The next 6 problems that I'll have up on the screen, the 3 odds and the 3 evens, they're all going to look exactly the same, with Kristen wanting to make a certain solution. And I'm going to solve these all with the same box information. Here's the idea as I read through problem 10. Kristen wants to make 30 gallons of a 40% alcohol solution. Maybe it's for some hand sanitizer, or I have no idea what she would want to do this for. But anyways, she doesn't have a 40% solution available, but she has a 60% solution and a 20% solution. So she's going to take a certain number of gallons of the 60% solution, mix it together with the 20% solution. So she's going to take a solution stronger than the desired amount and a solution weaker than the desired amount. And when you mix a 60% solution with a 20% solution, you get a solution that has a concentration lower than 60% but higher than 20%. So if you mix properly, you can move up the concentration of the 20% and move down the concentration of the 60% and get there to 40%. So always when I have these, I'm going to mix 2 fluids together that have a certain concentration to produce something that has a new desired concentration. I always start off and I make a box that looks just like this, has 4 columns and 3 rows. I make the top column or the top row called concentration, and I put the desired percent, I can't even spell desired, but the desired percent in the top right. And Kristen wants to make 30 gallons of a 40% solution. The desired percent is 40%. I put the other percents in either order that I have to mix in the middle 2 portions of the top row. What she's mixing is a 60% solution and a 20% solution. And it wouldn't matter if I flip-flop those. It's going to help me if I change the percents to decimals as I go through to figure out what my answer is. So that's the first step. Anytime I'm mixing a strong solution with a weak solution to get a middle solution, I pull off the concentrations and put them across the top row. Now I need to give names. I don't have any reason to make any special names, so I'm going to let X and Y be the different solutions that I'm mixing together. I'm mixing a 60% alcohol solution with a 20% alcohol solution. I'm going to let X be the number of gallons of the 60% solution that I'm going to put into the mixture. Maybe put it in some tub or big vat to get my 30 gallons. So X is going to be one of the items that I'm mixing. Y is going to be the other item I'm mixing. I'm mixing a 60% solution with a 20% solution with a goal of getting a 40% solution. All right, done with the top row. Super easy to get the second row, the middle row. The middle row is going to say the number of gallons of the 60% solution plus the number of gallons of the 20% solution equals the desired number of gallons. So I put the variables in the open spaces under the amount row, the amount of the 60% solution plus the amount of the 20% solution is going to equal the amount of the 30% solution. Eventually, I start doing that for my equations. I make pluses and equals. Done with the second row, and I even have the equation that I'm going to get from it displayed. And now I'm going to multiply down. I'm going to multiply 0.60 times x, and what this is going to give me is how many gallons of alcohol are in the x portion of my mixture. Like if I had 10 gallons of x, then 60% of that 10 gallons is going to be alcohol. If I had 10 gallons of x, I'd have 6 gallons of alcohol, because 60% of x is alcohol. The other 4 gallons is whatever they mix with the alcohol. So I'm going to multiply down. Multiplying down again gets the amount of alcohol from the 20% solution, because if I multiply the concentration times the number of gallons, that's the amount of the, in this case, alcohol. So far, I have the amount of alcohol from the 60% solution. I'm going to add that to the amount of alcohol from the 20% solution, and it needs to give me the desired amount of alcohol. Super easy to know the desired amount of alcohol. I need 40% of the 30 gallons to be alcohol. I'm just going to multiply down. I'm going to go 0.40 times 30. I need 12 gallons in my mixture. If I have a mixture of 30 gallons and it's 12 gallons of alcohol, 18 gallons of some non-alcohol, then it's 40% alcohol, 60% non-alcohol. So I just multiplied down, multiplied down, multiplied down. I don't really even need to think once I get these tables organized. And now I'm going to get a system of equations. So the middle row says the number of gallons of the 60% concentrate plus the number of gallons of the 20% concentrate are going to equal the 30 total gallons. The bottom row is going to say the amount of alcohol from the 60% concentrate plus the amount of alcohol from the 20% concentrate equals the total amount of alcohol that I need. So my system of equations as I'm going to solve is going to be x plus y equal to 30 and 0.60x plus 0.20y equals to 12. I just wrote solutions to these and I solved them by elimination. So I'm going to solve by elimination. You can solve by substitution if you care to. Let me show you what I did when I just wrote the solutions to the corresponding odd problems. I looked at the smaller coefficient in the bottom equation, and I multiplied the top equation by that number with the sign changed. So I'm going to multiply everything in the top equation by minus 0.20. I'm going to go minus 0.20 times x and get minus 0.20x. I'm going to do minus 0.20 times y and get minus 0.20 times y. And then I'm going to do minus 0.20 times 30 and get minus 6. So I'm going to transform the top equation so I could use the elimination method. I picked the smaller number because it makes the work at the end easier. Now I'm going to combine, canceling out the 20y's. In front of the x's, I have negative 0.2 plus 0.6. In front of the x, I'm going to get positive 0.4. I don't need the 0, but I'll put it in just because I have a habit of doing that. The y's cancel, and on the right side, 12 minus 6 is 6. I'm going to divide by 0.4, divide by 0.4. On the left-hand side, I get an x. On the right-hand side, 6 divided by 0.4 is 15. X is the number of gallons of the 60% solution, so I need 15 gallons of the 60% solution. Pretty easy to find the y. I'm going to use the equation x plus y equal to 30, and I'm going to plug 15 in for x. So I'm going to go 15 plus y equal to 30, and then minus 15 minus 15, and I'll get y equal to 15. This I knew. I can do this problem. If the result is exactly halfway between the two mixtures, you get equal amounts of each. So my answer is I'm going to need 15 gallons of the 60% solution and 15 gallons of the 20% solution. This, I don't know how important this is, but it's kind of important because it comes up in a lot of math classes, so I thought I'd throw these problems in here. We're going to do two more problems that are essentially exactly these problems with just different percents. So problem 12 talks about Kristen. Now she wants to make 600 gallons of a 34% solution, and she's going to mix 24% and 64%. So what did I do when I set this up? I always did the desired percent in my table. My table's going to be the same. Top row is going to say concentration, middle row is going to say amount, bottom row is going to say multiplied, and I'm going to pick out the percents from the problem first. The percents I see are 34%, 24%, and 64%. Always the middle percent's going to go in the far right because that's going to be my goal. I'm mixing a strong solution and a weak solution to get a middle solution. So the 34% desired middle amount goes in the last box, and in either order I put the 24% and the 64%, the solutions that I'm using to mix, in the other boxes. So I'm going to just change those decimals to the percents to decimals. Now I'm going to fill in the amounts. I know I need 600 total gallons. I'm going to use a certain amount of 24% solution, a certain amount of 64% solution, and that's going to add up to the total amount that I need. So what I'm doing is I'm making X the number of gallons of the 24% solution, and Y the number of gallons of the 34% solution. And it's going to be the number of gallons of the 24% plus the number of gallons of the 64% equals the total 600 gallons. Now I'm going to multiply down, do 0.24x, multiply down 0.64y. That gives me the number of gallons of alcohol from the 24% solution. This gives me the number of gallons of alcohol from the 64% solution. And I'm going to multiply down again and get 204. So the equation that I'm going to set up from the bottom row is plus and then equals. So the system of equations I'm going to need to solve is x plus y equals to 600 and 0.24x plus 0.64y equals to 204. I'm very consistent when I solve these. I solve them by elimination. I multiply the top equation by the negative of the smaller decimal. You don't have to, but that's the way I like to do it, so that's the way I'm going to do it. So now I'm going to go minus 2.4 minus 0.24 times x and get minus 0.24x. I'm going to minus 0.24 times y and get minus 0.24y. And then I'm going to do minus 0.24 times 600 and get minus 144. I'm going to leave the bottom 0.24x plus 0.64y equals 204. Cancel the x's. Now I'm going to do minus 0.24 plus 0.64 and get 0.4 or 0.40 y, and to the right of the equal sign I get 60. Now I'm going to divide by 0.40, divide by 0.40, and I'm going to get y equals to 150. So I need 150 gallons of the 64%, and it went off the screen. So part of my answer is 150 gallons of the 64%. I'm going to use the equation, if I can't do it in my head, to solve for x. I'm going to use x plus y equal to 600. I'm going to plug 150 in for y. And get x equal to 450. For an answer, I'm going to say it's going to be 450 gallons of the 24% and 150 gallons of the 64%. One more of these to do. I think maybe we'll just set it up and not solve it, and move on to the last kind of problem. And a matter of fact, let's chip away at 13. Let's try to have you set up 13, and maybe you can solve it at another time, or pause the video and solve it. So for number 13, it's talking about mixing alcohol. Let me make the box. I don't have the box ready. Not such a problem. Can make this box all day. So concentration, amount, multiply. Horribly abbreviated, but I didn't feel like writing it. So I need to have some columns, and I read through this. She wants a 25% alcohol solution. She's mixing a 16 and 28. The middle percent goes on the far right edge. The other percents, the smaller and the larger percent, fill in the rest of the top row. Now I'm going to deal with variable namings. I'm going to let x be the 16% solution and y be the 28% solution. So x is going to be the number of gallons of the 16%. Y is going to be the number of gallons of the 28%. And I know the number of gallons of the 16% plus the number of gallons of the 28% needs to be her goal, which is 32 gallons. Now I'm essentially done. I multiply down, get 0.16 times x. I multiply down, get 0.28 times y. I multiply down, get 0.25 times 32, which is 8. And now I'm setting up my equations. My equation, the number 13, would be x plus y equals 32, and 0.16x plus 0.28y equals 8. And I'll let you solve them. I want to do the last kind of problem, which is real similar, even though it won't seem similar. I'm going to be able to do it the same way. So that's why I grouped these problems. They're a variation of this box problem. Last two problems are mixing dried apricots and dried apples to make a mixture, like maybe something you'd buy in Sprouts, but in Sprouts they'll, mix M&Ms, raisins, peanuts, and coconut. They'll mix 4 items, and they have to figure out how to price it. We could do a complicated problem like that, but it would be a little bit much for what we have mathematically right now. But this is the idea, same idea. Instead of mixing a strong solution and a weak solution to get a middle solution, I'm mixing an expensive item with an inexpensive item to get a middle cost item. It's the same idea. Instead of going strong and weak to make a middle, I'm going expensive and cheap to make a middle. So in this problem, we're mixing dried apricots that are cheap for $3 a pound. I love dried apricots. That feels really cheap. Is mixed. So a mixture of dried apricots that sells for $3 per pound is mixed with dried apples that sell for $6 pounds. How many pounds of each need to be combined to make a mixture that sells for $4 per pound? The dollar amounts are like the percentages, and they're going to go across the top, and the middle dollar amount is always going to go in the far right edge, because I'm taking an expensive product and an inexpensive product, an expensive product and an inexpensive product, mixing them to get a product that costs between. So I'll make the first row the costs in dollars. So the costs I see are 3, 6, and 4. The middle has to go at the end. That's my goal. And now, what am I mixing? I'm mixing apricots and apples. I'd like to use A for the variable, but they both would be the same. So I'm going to make my x's and y's again. And my x is under the 3, and that's what the apricots are selling for. So my x is going to be the number of pounds of apricots, of dried apricots. And then y, it's under the 6, it's going to be the number of pounds of the apples. And I know that the number of pounds of apricots plus the number of pounds of apples needs to be the total number of pounds, and we're trying to make 9 pounds of this mixture, so that 9, the total number of pounds that I need, is going to drive off to the right. I've used every number in the problem. Now I'm just going to do the same thing. I'm going to find the cost of the apples and the cost of the apricots by multiplying down. The cost of the apricots is $3 times the number of pounds. The cost of the apples is $6 times the number of pounds. And the cost of my 9 pounds, if I want 9 pounds to cost $4 each, the whole lot needs to sell for $36. If somebody wanted to buy it all, it should cost $36 because I'm making 4 pounds that cost 9 pounds each. Now I can set up my equations. First equation is going to be the number of pounds of apricots plus the number of pounds of apples equals 9 pounds. The second equation is going to be the value of the apricots plus the value of the apples equals $36. So let me set up the equations and solve them. So I get x plus y equals to 9, and 3x plus 6y equals to 36. I'm going to multiply the top equation by minus 3 and use the elimination method to drop out the x's. That's going to give me minus 3x minus 3y equals minus 27. I'm going to leave the bottom equation alone. I'm going to cancel out the x's. Minus 3y plus 6y is 3y. Minus 27 plus 36 is 9. And then I'm going to divide by 3, and get y equal to 3. Y is the number of pounds of apples, so I'm going to need 3 pounds of apples. I'm going to solve for x. I'm going to use the equation x plus y equal to 9. I'm going to plug 3 in for y, which is the number of pounds of apples. I'm going to subtract 3, and I'll get 6 for x, which is the number of pounds of apricots. For my answer, I'm going to do 6 pounds of the apricots and 3 pounds of the apples. There's my 9 pounds, and it's going to cost just enough. The 6 pounds of apricots will cost 6 times 3 or $18. The 3 pounds of apples will cost 3 times 6 or $18. I'll have $18 worth of apricots, $18 worth of apples to get the $36. Let us just set up problem 17. Maybe you can try to set up problem 17, but I won't solve it just to keep the video at a reasonable length. So I'm just going to get you ready to do problem 17. Pause the video and do it yourself would be great. I'm going to get lazy in my labeling of this box. So it's exactly the same question. Talks about mixing apricots and apples again, just so they have different values. And the values that I see here are $9, $2, and $7.60. always, when I go to fill in the costs, the middle cost, just like the middle percent, needs to go in the far right box, and the other costs can go in either of the boxes. The middle row for all these problems has an X and a Y, and now X is going to be the apricots for me, so X is going to be the number of pounds of the dried apricots, and Y is going to be the number of pounds of dried apples. I don't really know what these sell for. I usually don't buy dried fruit. I love it though. So I've almost used all the numbers. I have one number left, and that's the total number of pounds that I need between the pounds of apricots and the pounds of apples. That's going to go in the far right-hand corner. That's going to lead me to my first equation. Then I multiply down, and multiply down. Going to need your calculator to solve, I'm sure, because of that decimal. The equations that I would solve for problem 17 would be x plus y equal to 20, and, oh, I guess that's not that bad, and 9x plus 2y equals 152. You're still going to need your calculator, but the decimal got destroyed by the multiplication. For what it's worth, I have an answer, and my answer was 16 pounds of the apricots and 4 pounds of the apples. Assuming I have a correct answer, that's what you should get. So I'm going to pause the video. Hopefully you can do the algebra without me doing the algebra. If you can't, I've done this on my solutions. Go under the solutions tab and you can see how I worked it out. Although how I worked it out an hour ago might be different than how I worked it out now, but you'd get the same answer. There's multiple ways to solve these problems. All right, so we just need to master the practice test for chapter 3 and get ready to take our test.